Welcome to Ultra-Concurrent Laboratory on Inverting Operational Amplifier. It has two different configurations, standard configurations and high-gain configuration. This laboratory in total has 216 different inverting operational amplifier combinations. The standard configuration is used to observe the relatively low and medium voltage gain of the amplifier. The schematic view shows the variations in 4 circuit parameters and 1 signal parameter. In the schematic of standard configuration, it is possible to select one of the 3 possible values of resistor Ra. Similarly, it's possible to select one of the 3 resistance values of feedback resistor Rf. This laboratory also has the feature of varying the input signal voltage and frequency. The input frequency can be one of the 3 values, and voltage can also be one of the 3 possible values. And there is an option of selecting op-amp with lower and higher performance parameters. The circuit view shows the real-time implementation of inverting operational amplifier on the breadboard. The LEDs indicate which combination is being in action at the given time. Oscilloscope view shows the time response of the inverting operational amplifier. Oscilloscope has 2 waveforms where yellow corresponds to input and the blue corresponds to output waveform. The Bode diagram shows the frequency response inverting op-amp. Let's start the analysis with Ra of 1 kΩ, Rf of 10 kΩ, voltage of 0.1 volt and frequency of 100 Hz with 741 op-amp, which is having relatively lower performance parameters. With the input sine wave frequency as 100 Hz, observe the peak-to-peak amplitude of input and output are 1.99 volt and 203.40 mV respectively, thus confirming gain of 10 in magnitude. The output signal is 180° out of phase with that of input. The Bode plot of the circuit also shows a DC gain of 20 dB at a low frequency 200 Hz and the corresponding phase is 180°. The 3 dB bandwidth is found to be 51.2 kHz. If the gain of the amplifier is changed to -1 volt per volt by choosing the resistance values of Ra and Rf as 10 kΩ. The oscilloscope view shows a gain of almost 1 and the Bode plot readings are DC gain of -0.1 dB at 200 Hz and 3 dB bandwidth increased to 354.4 kHz. This demonstrates, as the gain of amplifier decreases, the bandwidth increases. The above process is carried out for another op-amp OP37 with better performance parameters. In the first case with Ra equal to 1 kΩ and Rf 10 kΩ, the gain and bandwidth are 20.02 dB and 202.04 Hz respectively, and the 3 dB bandwidth is increased to 1.754 MHz. This shows that the op-amp OP37 with larger open-loop gain has better bandwidth compared to that of UA741. Like this, the analysis can be done for other combinations of resistors, signal amplitude and frequency. In high-gain configurations, it is possible to analyze the performance of the amplifiers up to a gain of 100 volt per volt. Let's start the analysis with Ra of 1 kΩ, Rf of 100 kΩ, voltage of 5 mV and frequency of 100 Hz with UA741 op-amp. With the input sine wave frequency as 100 Hz, observe the peak-to-peak amplitude of input and output are 11 mV and 1.12 volt respectively, which demonstrate a voltage gain of close to 100. In the Bode plot, the DC gain is 40.04 dB and phase is 176°. The 3 dB bandwidth is found to be as low as 2.82 kHz. The similar analysis for OP37 shows a DC gain of 40.06 dB with bandwidth 284.54 Hz and the 3 dB bandwidth of 192.08 kHz. This again confirms that op-amp with better performance specifications will have greater 3 dB bandwidth and closed-loop gain. This way you can repeat for other combinations of resistors and voltage values under standard configurations and high-gain configurations. Please subscribe to LabsLand and perform all different combinations and understand the inverting operational amplifier concepts thoroughly.